All right, we can go ahead and get started. We've got a few folks online and we should be unmuted. For the people online, um, you are welcome to unmute yourself to ask questions at the end. Or Eric, if you want to field questions in the meantime, let me know. Otherwise, we'll just hold questions till the end. Um, and um, and I'll also be monitoring the chat online in case we need. But for those who are here in Boise, welcome. I'm excited to have this presentation. For those who are not familiar with BSUG, hopefully all of you are, but always want to just welcome those who might be new to the lecture series. This is sponsored through Idaho Power, so we're very grateful to Idaho Power's energy efficiency team for sponsoring delicious sandwiches for those who are in person, and those online are missing out. We are at the IDL, a branch of the College of Art and Architecture, and kind of a research wing, if you will, a mix of graduate students and research scientists and faculty. And she defended her master's thesis on Monday. She did awesome. So she's going to graduate next on Monday. So we're happy for her. And we're looking to welcome a couple graduate assistants in the fall. Other programs that we have, just in case you've forgotten about them, we've got our energy resource library, 900 tools available to assess building energy performance for any Idaho Power customer. So reach out to us on that. We have our technical design assistance program through Idaho Power. So if you've got a new project, a new technology you want to consider, reach out to us and we can be your virtual helpline, if you will. Gives our students an opportunity to explore real world energy efficiency projects. Up to $3,000 worth of our time, cheap faculty graduate student time, is completely free to you. $3,000 to $5,000, that's when we need to check in with Idaho Power to make sure it fits within their scope. We send that kind of scope of work to them. They give us the thumbs up or thumbs down within 48 hours, and then we get to work on the project to help you on maybe doing something with ComStock or an energy efficiency analysis. More than $5,000 worth of our time. We want to make sure that the client has some skin in the game. And so there's a cost share where the client will pay 25%, but Idaho Power will cover 75% of our time. It's a great resource available to anybody in Idaho Power service territory. But then Idaho Power, they've also got their own programs. Sri, I'm sorry, you're eating a sandwich. But if you wanted to mention anything above and beyond the regular commercial and industrial programs that you can find online on the idahopower.com/business. And
just reach out to me if you got any questions. We do have a new home building program as well. So if you want to talk about that,
great. All right, and I will move us past this intro stuff so that we can get to the main presentation. So let me stop share here. And Eric, I'll let you start to get set up. If this turns on, and then switch to HD. And then share my screen again. Not showing that screen as an option to share. Hang on just a second. Okay. It's showing PowerPoint. Hang on. I need to that. For the folks online, are you seeing the National Laboratory of the Rockies intro slide or just a big U of I logo?
Just the logo.
The logo?
Yes.
Well, that's okay. Dylan, you wanna, if you can assist here real quick while I introduce Eric. So Eric Ringgold is a longtime supporter of BSUG, so we're happy to have him back. You've encouraged us to be more tech savvy and to actually work on scripting, like you gave a presentation on that before, and it was very influential for me of kind of trying to remove the intimidation that can occur with scripting. It's like sometimes you just need to start trying, right? And you increase your expertise as you go along. Eric has over 10 years of experience in consulting and commercial building efficiency, including modeling for code compliance and meeting client energy efficiency goals. Now you're a senior researcher in the building stock modeling and analysis at the National Laboratory of the Rockies, where you develop tools to evaluate energy use of commercial building stock, which you're going to share today as soon as we get our tech sorted out.
Can you email me the presentation real quick? Because Word first of all, it's just not picking up your computer. It's one of the and
That's not.
it's only set up to this screen. So even though that's sharing to that screen, it's coming from the computer screen. So you can buy. Yes. Or John. Yes, but hold on, I'll say yes, we can email.
Your email got rejected. Well, right, send you guys that. Training.
Just waiting for it to sort out. Show up.
Oh, wow.
You need to have the presentational source. I thought you were virtual, so I didn't bother to double check. I was just like, you just share screen, you're good to go. I don't know why it's. I'm not sure.
It's 27.
Well, I even check architecture, it's like pretty sure it's. You know, not too bad. You know. My phone, but I know this is somewhere else.
It's good.
Well, I like that here.
That's pretty fast.
Well, ComStock is thoughtful. Like that.
Yeah. Wow.
Why? Everything's super fast. You give it to the. Why are you showing? Oh. Everything should be.
All right. Our apologies for the delay. What showed up on the screen in the room that looked great did not show up for the people online, so we had to reroute it to a different computer.
Good to focus on that. Yeah. Hi everyone, Eric from NLR. Glad to be back talking about what we've been doing with ComStock. So this is a new presentation. We have a ton of presentations, but not really for like a modeling audience or a BIM like practitioner audience. So put this together. I was kind of excited to do it, and yeah, hopefully it goes well. Just quick learning objectives. So I want to get into the guts or into sort of the details of ComStock, of what it takes to characterize a building stock for modeling, the actual building the models, running them, post-processing, bring it back to some lessons for sort of BIM practice generally. This is putting back my my BIM consultant modeler hat on and thinking about what would be what I would want to take away from that, and then we'll talk a bit about the applications of the building stock data. So about ComStock, mainly ComStock attempts to answer two primary questions, which is where is energy used in the U.S. building stock, and where geographically, by what building types, what end uses, and what times, and what impacts do technologies have on this. So the technologies is important because we use building energy models to determine, like physics-based building energy models to model the stock. And in doing so, we can run measures on them, run different technologies, have all of the interactive effects of those technologies captured in those models. So rather than sort of a top-down data-based stock energy model, we're doing a bottom-up. So we're trying to straddle this this continuum between very low granularity, which is what you get from like prototype, the DOE prototype building suite, or very high granularity, which would be something like model every building, which is computationally and time infeasible, right? So we're trying to end up in the middle here with modeling. Basically, we end up with about 150,000 representative building models that are representative of the entire building stock to strike that balance. So quick run of learning objectives for the presentation. We'll identify key challenges in creating this national scale building stock model, understand the workflow for generating, running, and processing the models, evaluate the lessons learned, and some of the use cases for modeling data. So the starting point for all of this is sort of stock characterization, right? We need to know what is the building stock in order to model it. So again, like I mentioned, we take a bottom-up approach of modeling the stock using available data to sort of characterize or get all of the building characteristics. Of course, in real life, there are 6 million commercial buildings in the United States. We don't know most of the characteristics about all of those specific buildings, but we do have a sense for what the distribution of those characteristics are from the various source data that we have, and I'll get into that. So we represent those 6 million buildings by 150,000 models, and we do that by first sort of binning the characteristics that we would input into the models, and then creating sort of probability distributions of those characteristics at those bins. So for example, for exterior windows, There's a whole range of sort of window thermal resistances in windows out there, but we can represent those sort of as chunks of thermal resistances, and the probability is that a particular building would have that particular thermal resistance. So think about that as sort of one building characteristic, and then we're doing that with sort of all the building characteristics that that are necessary for generating models. These are just a quick overview of some of the data sources that we use for this. Big one is CVAX, also American Community Survey, helps tell us what building types exist, what their vintages are, HVAC systems, and then some of the energy truth data mainly comes from CVAX. Commercial real estate or Department of Homeland Security data. This we use sort of proprietary commercial real estate CoStar data, which is basically every building that it could be bought or sold, commercial building. So we get a lot of commercial information there, mostly around floor areas, sizes of buildings, types, and then where they are in the country. The buildings that aren't bought and sold, things like hospitals or schools, that a lot of that comes from Department of Homeland Security. They have like infrastructure data based on for those types of buildings. So we compile all that together to get this information on size of buildings and where they are. Of course, building energy codes and standards gives us what, you know, envelope thermal performance should be, system efficiencies, and since those are set kind of at various points in time, we can compare those to the vintages we have and get a sense for what the characteristics of the buildings from those vintages would have. We use a lot of industry data for things that are more kind of not quite set by codes, or maybe like are limited by codes, but in reality are something else. So this would be like lighting technologies, window performance is like what is actually out in the market in buildings. And then we do incorporate some sort of aggregated BA building automation system data to refine assumptions around occupancy, usage, kind of when things happen with building. So we kind of take all of that data and then create for each of these characteristics probability distributions that have in themselves like dependencies, right? So we can start off with at the climate zone region, and then from climate zones we can sample sort of what counties are in those climate zones. For each county, we have a distribution of the building types that exist in there, again from that real estate data, and then based on the type, we can generate probability distributions of vintage, square footage, number of stories, and then a bunch of downstream characteristics from those kind of things. So, so with this set, we create basically a big n-dimensional matrix of building characteristics that are then sampled. That huge matrix can then be sampled to get representative sets of characteristics for the buildings that we want to model. Example of what those characteristics are for a particular building is shown here. Things like, again, building type, year built, floor area, etc. Note that we don't specifically define, and that so this becomes essentially like the one input row, or one row of input data for one building model in ComStock. We don't specifically define all of the parameters for window, thermal resistance or HVAC efficiency or type or things, or we have HVAC type, heating fuel, heating type. But instead break that stuff down into this energy code following during last replacement sort of input for each of those major load types. And that's important to say, to then populate sort of all of the details of the model from that. So we just say, I identify like, here's the energy code that would have been in place at that last time that the HVAC system is replaced. And given that, as well as the HVAC system, we can look up the reference or like the actual parameters on system efficiency, system controls, et cetera, and populate the models with that. So this kind of reduces the input burden a little bit by just having those sort of templates to follow in generating that performance data. Also note we have occupancy schedule information broken down to weekday and weekend operating hours and start time. And that's important for adjusting the schedule of the buildings. Again, we don't need anything more than that because the sort of downstream code can take that to populate the whole building. So that sort of sets the input kind of, sorry, I'm trying to go fast here to make up for some time. So we take that input and then we need to build runnable Energy Plus models with those. So the model creation process is at a high level, it's fairly simple. We have the BuildStock CSV, which is a CSV of that input where one row is a building, columns for each of the sort of major characteristics. And then that's paired with this options lookup TSV, which is sort of like the recipe book index, right? It's like where you can find the specific set of instructions for making each menu item, where the menu items are defined in the BuildStock CSV. So both of those sets of information is given to this measure build existing model, which you can think of as the chef. It takes those instructions, and what they're supposed to be building or making, and turns that into a fully featured baseline OpenStudio model, which can then be run as an Energy Plus model. When we apply model upgrades, which is an important part of what we're doing with ComStock, we have a separate the companion chef apply upgrade that takes the output model from build existing model as well as the characteristics from the options lookup, which have the full characteristics of all sort of baseline and upgrades that we want to do, and then modifies the building in specific ways to create the upgrade model. In reality, so this high level, it's pretty simple. In reality, it gets a lot more complicated when you look into the individual steps. So the chef measures are really orchestrating this whole team of sous chefs that are each sort of tasked with a specific job. And each of these is sort of a sub-measure that does a specific thing in building the model. So, for example, the building location information, the weather, the design conditions, site conditions are set in one measure. Simulation settings are tweaked in another. The building geometry is created. The building is populated with internal loads and systems and controls in the create typical building from model measure. And then inputs are adjusted with each of those set HVAC templates, that roof template. Those additional measures will then change the building in specific ways. And similarly for apply upgrade, we have a large suite of upgrade measures for ComStock. I think it's in the dozens right now that make specific modifications to the build baseline energy model, again with their options provided by the options lookup. The individual upgrade measures kind of will determine, based on characteristics from the baseline model, if they should even apply. So there's a whole sort of set of applicability checks baked into those measures to say, hey, does it make sense to try to apply this modification to that model? Maybe that model doesn't have the objects or the things that we want to modify, so we're not going to even try, or we're just skipping them for various reasons. So the applicability is sort of determined there, and then if they apply and they make the changes to the model, and then that upgrade model is created. So for all 150,000 baseline models, we're running, like I said, so the total number of upgrades in our most recent release is something like 65. which includes upgrade packages. So it's both like, upgrade the walls and upgrade your systems as a package, but including all of the upgrades that we run, it ends up being something like 9 million models that we create and then simulate on the NLR high performance computer. Creates, I think, hundreds of terabytes of data, of output data, because we generate a ton of characteristics, output characteristics from each run, as well as time series data that to publish with the release. All of this code, should we say, is available open source on these two GitHub repos. So ComStock is the main one that orchestrates the ComStock model, and then Open Studio Standards is really where a lot of the heavy lifting is done. I forgot to mention this with the build existing model. Most of the code from these individual measures actually comes from Open Studio Standards that has the really sort of worker functions to say, create these model instances, populate them with this data. And that's really where the bulk of the actual model building is done, is in this Open Studio Standards Ruby gem that exists, that can be used for all sorts of things, not just this model articulation kind of stuff. Open source code. All right, so that was sort of really quick about building the models, but there's sort of a lot to it. After we create those 9 million models, simulate them on the high performance computer, then we just get model output, and then we have to do stuff with it. Again, that's not the full, the final sort of stock data. That's just our sample of representative models, and then we need to turn them into something that is actually usable as the national building stock. So that's done in this weighting and allocation process. This gets pretty technical, I would say, but essentially what we're doing is we take the simulations that we've run, and we have the truth data about all of the buildings that we know exist, the commercial buildings that we know exist in the country. But we don't know everything about those, such as the major sort of segment variables are fuel type and HVAC system type. We don't know for all of 6 million. So we have to sort of impute what those are and then match them with specific models that we've run. So this kind of describes that process. We take all of those 6 million models, do this bootstrapping process where it give everything sort of a 1/3 weight at 3 times each building, and then sort of take a guess at what the fuel type and HVAC system for those might be with those probability distributions that I discussed earlier. After that guess, we can match them to a synthetic model or a synthetic building model, and then change those weightings so that the total area and energy use matches or the total actual area matches the truth data that we know from CVAX. And so we do this weighting process. We end up with the data of multiple building IDs repeated with individual weights, but the total of those matching at the census tract level what the sort of total building square footage should be. Kind of a difficult thing to wrap your head around. I admit that I'm not even 100% on that, but it's a complicated post-processing that we have to do with all of this data in order to create something that is national representable and that you can sort of drill down to the census tract level and have it be representative of the building stock at that geography. We also take kind of a detailed calibration approaches or calibration checks that we do every time we make a data set release. Actually, every time that we make a baseline modification, we're doing these sort of high-level comparisons to CBEX data. These comparison plots are, so CBEX releases, energy use by building for their whole data set. That energy use comes with some error bars, so we represent those total uncertainty ranges on the CBEX bars in green, and plot the ComStock results segment, divided up by building type, by fuel type, and by census division, and we do end use as well. Although I should note this, the end uses published by CBEX are the end use energy is itself modeled end use energy, and I think some of the assumptions that EIA makes in modeling those end uses come from ComStock. So it's a little bit of a sort of circular thing to compare against those end uses, but this is really instructive from a model calibration approach, and when we're making baseline adjustments to see like what segments we are doing well on, what might need work, and then taking that and starting to think about what it is about our models that could be improved, either in the models themselves, in the sampling approach, in the weighting and allocation approach. There's sort of many places at which we can sort of apply the learnings from the calibration. And that extends to time series calibration as well. So we make these AMI comparisons based on anonymized, aggregated utility AMI data that we've received from a handful of utilities across the country. And by sort of selecting the equivalent ComStock model geographies for those types, we can create these plots of time series. So the colored end uses are the ComStock data. The black solid and dotted lines are the AMI aggregates and their sort of confidence interval ranges that we can calculate from that data. One of the sort of difficult things about these AMI comparisons are the AMI data that we have is not super, there's not a ton of it. So I don't know if you can see the AMI, there's an N equals 7. That is like the number of comparison, basically meters that we have for this particular geography. This is in Maine, large office is in Maine. So a fairly small region of a specific building type, not a lot of comparison samples. This is something that we would really like to do more of this type of comparison from. Getting AMI data from utilities can be difficult, and so this was the result of a big calibration effort that was done a few years ago. But then we can continually make these plots to inform sort of where we're doing, and yeah. What I'm showing here is our normalized days. So the plots are all sort of normalized to the total, to the days for the summer, winter, and shoulder seasons. But we also make them for sort of normalized load. So this would be the load charts. This particular one looks pretty decent, but you definitely see that, say on the summer weekday where we're underestimating like the extent of the operation, I guess, for those buildings, and the winter weekend we're also obviously not as high as the total load that we're seeing from this AMI data. This is my plug for utility folks that we're always looking for more utility data, and it really goes a long way in improving the models for different, for the whole country, but really for the service territory that we would have the comparison data for. Okay, so time doing all right. Bringing this back to BIM practitioners. So that was a lot of sort of high level, a lot of like in-depth research stuff. So what can this sort of teach you as a BIM practitioner about that might help for your workflow? So the first thing, which kind of gets back to my previous present talks at this forum, is automation. So even when running single buildings instead of hundreds of thousands or millions, being able to use sort of an automated, reproducible workflow has huge benefits in terms of time, quality, QA, and yeah, it's just even before I joined the lab, when I was working in consulting, I found that that this has a ton of benefits. So this means not doing sort of everything over and over again by hand, but sitting down, figuring out what you want to do, what your sort of standard process is, and writing that as instructions for a computer to follow. The second one is to standardize. So as I was mentioning before, with the apply measure with the apply upgrade measure, we have this list of measures that you kind of just throw at a particular building. The measures themselves contain sort of the know-how as to say whether to apply to this particular project or not. So for different projects, for commercial new construction or retrofit analysis, you might have like a standard list of measures or measures that only apply to a specific building or a specific location. When you craft those measures, to think about how you can determine whether or not it applies and then just put them all in a big workflow can save you a bunch of time in going and piecing together a workflow yourself to say like, oh, that for this project, I want measure A, B, and C and F. Instead, you just run your list of measures and know that they were made in a way that, based on the models that you create, that it's not going to run D and E. There's a lot of examples in the ComStock upgrade measures on how we apply the applicability logic. So going and looking at things in the model, determining if it can be upgraded and whatnot. To reuse, so recognizing that not all BIM practitioners have the resources for model and measure development that researchers at a national lab do. I put up the repositories to say, go and look at the code that we have and reuse it and apply it to your practice. So a lot of the measure or all of the measure code that we create thoroughly reviewed, embedded. In many cases, it includes specific technology performance data that either comes from lab testing that we did or manufacturer data that we can compile for specific technologies. So all of that is available in the upgrade measures, in Open Studio standards, and can be used or reused in different ways on projects. So definitely suggest reviewing what's available as a starting point for your analyses, so you don't have to redo a lot of that work. In terms of validation, in addition to using our modeling approach or code, you can directly use the data. So one thing that I've been working on with Autodesk is ways that they can take our kind of stock level results and use that to benchmark or compare, create a comparison for typical building performance for to put up against a new building project of similar types or climates or things like that. So all of the data that we publish, the simulation output, the metadata, the time series data, it can all be filtered and processed and compared against whatever you would like and applied to projects in that way as comparison set. And then on the last note, the replacement, we also published the ComStock models. So the ComStock models necessarily contain like a wider range of input and found in actual typical buildings than say the DOE commercial prototype models. Any use for the DOE commercial prototype models, I think, would be improved by sampling models from ComStock that sort of meet the range of interests that you're trying to that you would use a prototype model for. Those prototype models can be highly idealized. They have sort of uniform and unrealistic schedules, and I'm pretty sure they follow like the standards allowed, say, lighting power, rather than what you would typically find in buildings. So all of the end models that we generate are also published with our data and can be pulled and used and modified and however you would like. To that end, we have sort of a number of data access pathways. So we publish CSV and Parquet files. There's the sort of annual metadata files at various levels of pre-aggregation. So we do publish files that are aggregated up to the sort of national county level, or all the way to the individual tract level if you want the full, the big ones. We have published individual load profiles and aggregate load profiles, the time series data, and then we have data viewer, and then everything's up on S3 buckets. So you can set up ways to automate the access to those. We do not have a data access API at the moment, but it's something that has been requested, and we're definitely considering putting together. So yeah, finally, just so that all gets into the modeling details, and then you might ask yourself, well, what can we do with all this ComStock data? Not necessarily the models itself, but stock level building energy data. So one thing that's been used for climate action plans. The lab worked on this LA 100 study to inform the city of Los Angeles and the LA Department of Water and Power on possible pathways to 100% renewable energy. This was a multi-year project that finished a number of years ago, but was sort of a real initial testing ground for the use of stock level data in this way. So with ComStock, we can characterize their building stock at a state level, at a utility territory level, identify kind of the segments of the stock that might be addressable with various mitigation measures, and then using that upgrade data to assess like what you can expect from the adoption of those measures. Additionally, it can be really useful for grants, rebates, incentive programs, for all of the major end uses for which we have upgrade measures for. We do include utility data or utility bill data in the data set. For commercial, it's a little bit difficult to really set a single tariff for a building. So instead, we kind of model a range of potential applicable tariffs, but that sort of utility cost information can also be obtained from the data. So you can do things like cost effectiveness calculations and other things. So it's been used by Minnesota for applying to their programs. Back to the sort of the issue with the prototype buildings, as I know a lot of the prototype buildings underlie a lot of assumptions around utility incentive programs, and I'm not sure that the ComStock models have really been integrated into those sort of measure analysis processes, but I think they would be really useful there. we've also seen it used by utilities for load forecasting, again, with building stock characterization, pathway identification, and looking at sort of the load growth impact from various measures, or specifically to their service territory. Again, we get this because we have a really a really granular sort of geographical representation in the data. And there's more, but I thought I'd be running out of time, and I guess I am. So yeah, that is all. Thank you.
One from online, Jamie Baucus was asking here. We've got Oak Ridge National Labs, Model America, plus the ComStock desktop solutions, like states and cities considering a BPS. Most BPS are top down using self-reported EY data and locations. I create a target, just call it a day. What would a bottom-up approach applying, say, electrification, energy conservation measures show the potentials, greenhouse gas emissions, EY reduction?
What would it look like? I mean, I think that it certainly could be done. I know of I believe there have been some uses of ComStock and RedStock for developing BPS. And so, yeah, people have definitely explored it. And I feel like it's a great use case for it, because again, we have such a variety of measures already modeled, and the stock kind of characterized for various geographies.
Can the ComStock help replace or update ComNet Appendix C schedules? For example, can we readily use the domestic hot water loads for multifamily and hospitality serving models?
Potentially, I would say, number one, we definitely have work to do specifically on multifamily and specifically on surface hot water. So I would say not, probably not at the moment that the schedules could be dropped in instead of ComNet. Also keep in mind, yeah, but what we're trying to do with the schedules is take more of a typical representative approach, not a sort of design level representation of the schedules, which I think the ComNet schedules are more likely to represent, and so that might have various implications to how you're using them on a design project.
Question for you.
Yeah.
Curious, so we've been switching over to the Appendix G building performance factors and struggling to meet those. Those are based, I think, on the prototype models.
Mm-hmm.
Is there any collaboration going on with DNL and ComStock to kind of validate some of those performance factors?
That is a good question. I don't know of any currently. Yeah, I'm not sure. I guess that Jason Glazer on the. But yeah, that's not a bad suggestion at all.
Question for you on the amount that's model versus data that you have collected. A lot more utility information networks and things across, but you said that it's kind of a weird interplay between ComStock and CVEX for in use. How much of CVEX is modeled versus like data that's captured, like for things like I don't know, internal uploads, for example? Do you have a sense?
So I believe really just the end use data in CBEX is modeled. And if you think about like what, you know, CBEX is a survey, they'll ask you for your, you know, total energy use, which you can get from your bills. But for a typical building, like they're not going to know, you know, what their lighting end use is, right? In terms of annual energy. So it makes sense that I think that, yeah, I believe there are questions on, you know, what the characteristics that that drive the end use energy are, and I think that they pull that in the development of the end use assumptions. It's been a while since I checked the CVEX methodology, but I think they kind of get into this in their methodology documents. But yeah, as far as I know, that is the extent of their model data, and everything else is sort of direct survey, where they do impute answers to some of the questions based on other things. Like if they didn't receive a particular answer, they have like an imputation process for filling in that missing data, which I suppose you could call it modeled result, but yeah, not same way that like the end use breakdowns.
You also include CSA, like stock assessment that's more regional in the Northwest. Do you know how that much that overlaps with CVEX?
We so far have focused mostly on nationally available data. That's because mainly because we're supported by DOE and that's what they're interested in, right? I've done a lot of looking at the CDSA, right? And then there's a California one, SUS. And I think that there might be other sort of more state-based like building characteristic surveys. It's certainly an area that we have talked about trying to incorporate that that more locally specific data. Usually comes down to issues of funding and to, you know, to support that. But I think that's something where, you know, if there was a regional organization, like if NIA was like, we would really, you know, it would help us a lot to have ComStock more represented in this. You know, we'd be happy to talk to them, think about ways to incorporate that data.
Thank you again, Eric.
Yeah.